Welcome back. Day 7, Advent of Code 2016, Internet Protocol version 7. While snooping around the local network at Easter Bunny HQ, you compile a list of IP addresses. They're IPv7, of course. IPv6 is much too limited. You'd like to figure out which IPs support TLS, Transport Layer Snooping. An IP supports TLS if it has an autonomous bridge bypass annotation, or ABA. In ABA, any 4-character sequence which consists of a pair of 2 different characters followed by a reverse of that pair, such as X, Y, Y, X. So it's like a palindrome, I guess. However, the IP also must not have an ABA within any HyperNet sequences, which are contained by square brackets. So we want ABA here and we don't want it in here. So this is ABA, or this supports TLS. And then we have a palindrome in here, so we don't support TLS. Even though there's outside. Okay, then we have this one, does not support because AAA is invalid. Interesting. They must be different. Then we have supports TLS. OXO is outside square brackets, even though it's within the larger string. Okay, so strings are also larger. Okay, so here's the middle. And we also have multiple. So here's one. And here's one. And here's one. So we have to figure out the parsing as well. Let's try it. Let's get the normal example. Okay, so I want to figure out how to, definitely per line I can work. Then we have the problem is we have to also handle this case where it's 2 groups of brackets. I'm thinking of using the split, but then function but that makes things harder. Maybe I can just literally walk through the string. While I smaller than line dot length, I just check, like, and I have var inside is false, and I check if this is, or when this is this, then inside is true. Don't appear to do anything else, and then inside is false. Yeah, whenever we hit these, we have to also evaluate our string. So else we have a character we can add to our string. Say we have string is like a, or I guess a mutable car list, and then we just add things to this string dot add line I. Yeah. And then let's say I hit this guy, so I add 4 things to my car list, and I hit this. Then I should evaluate my string, which is join to string. Now I have to check if it is a palette, if it is a aber. Is aber. Okay, let's do it later. If is aber, then, or has aber even, or contains aber, then I can set my var found aber is to true, and I need another one, var not invalid. Okay, valid equals, this is assumes true, found aber is false at the beginning. So if I found aber, then I can say found aber is true. And then if I have here, if I close this bracket, that means I collect it. So yeah, after that I first of all just reset it. So I found 4 things. Did it? Then I hit this. Then I check has aber. It has aber, so I do true. I have an aber. Nice. String reset. Next characters, these 4 I collect again. Then I hit closing bracket. The problem is if I found an aber in this case, I should set valid to false, because if there's an aber inside brackets, the whole thing is invalidated. And this way I have valid and found aber, and I can if found aber and valid, then we see what we want to do. How many IPs? So we increase some kind of result counter. Let's check that we have this guy. So don't even need this. Oh, yeah, we don't need it because we just reuse the string. So the only thing we need is to figure out if some string contains aber. So we just check the string. We need to do some kind of loop. Drop 3 for each index. I take substring of I2 I plus 4, should give me a string with 4. So that could be aber or something. Then I need to check if it is aber in the sense that this is not equal to this. So the first 2 characters here, A and B, need to be different. And string 0 has to be equal to string 3, and string 1 has to be equal to string 2. Then we have an ABBA. So we can just say false, result is false. If we find this, we set it to true. And after we tried everything and checked if we find something, we can return the result. Let's see what we get. Also be cool to see print line has ABBA. Okay, what's going on? Yeah, problem it contains ABBA. Let's drop do again. Except the first. Is there a nicer way to do it? What is the other one called? Or take this dot indices dot size length. This dot indices dot last -3. We just take 1 in the case of a 4-digit character. Okay, we have this one has ABBA. Let's see, is that the only one? Support does not. No, the last one supports. Oh no, we have this one supporting. Oh, I guess. Oh, why is the first one not counted? Has ABBA here in the front. So we did find a more complex one. Let's just see what happens in the first case. So we have ABBA. Well, what is my string actually? Here, this is ABBA. What does this do? Oh, the index last is 3, so it's 3 minus 3. Okay, so I want 3 minus 2 actually. The last index is 3, 0, 1, 2, 3. So I want, in the case of 3, in the case of last index being 3, which is the length of the... Oh, that's so confusing. Let's just do this dot length minus 3. Here, this is easier. Okay, now we have it. This one has ABBA and this one has ABBA. Let's try the real thing. Also, I wonder if this worked. Yeah. And I wonder if this would invalidate it. Yeah. Okay, let's try. So we have 83 ABBAs. Oh, valid IPs. Ooh, that's not right. Let's see, did I copy it correctly? Yes. What? I didn't even give us an indication if it's too little or too big. So it's hard to know now what we might have done wrong. Let me try my own edge cases a bit more. I wonder if I can find it. Yes, I can find at the end. At the beginning, right? Okay. What if... and if it's in here? Okay, we didn't have that problem with the real data set. What if... what this case? I know we have a test case for this basically. I wonder what else could be in these examples. Maybe I'll print them all. Be hard to find a bit. Line does not have a bar. Let's have a look. So this is really hard to find. Check the question again. How many IPs in your puzzle input support TLS? It supports TLS if it has a ABBA. An ABBA is any 4 characters even which is a pair of 2 different characters. Yeah, I think I clarify that it's 2 different ones, because these are different. 0 is the same as 3, and 1 is the same as 2, so that means we have only 2 different ones. And that means we do have 2 different ones. Oh, I see something. I didn't reset the string here, because obviously after I collected all the characters into my string to validate this, I need to reset it the same way I reset it up here. Let's see what I get now. 77. Try that. Still wrong. Okay. What else could it be? I have one more idea. Actually, that's an easy thing to test. This one. Yeah, it says it doesn't have ABBA, but it does, and the problem is that I evaluate only when I get a bracket, and I don't get a bracket at the end of the string. So I could evaluate again, Just don't know if I can know that I'm always outside of a string. I don't know how to get to my big example now. It looks like it, right? We can test it. For each line, check Let's do this. First open, is this? First closed. Oh, I guess it's not the first, it's the last, because I reverse the string. I want to find out what if the last closed bracket always has a bigger index than the last open. Guess I can do this if it's smaller, print line closed smaller than last open. So the open is later. Let's have a look. Aha. But because no, I want the other way around because it's reverse, right? Let's see. Oh, there's so much printing stuff here. Okay, everything is the same. Everything has last closed later than last open. Because in the reversed string, last close is greater than last open. Okay, and the point of that was to show that I can now assume that this is always the case, that the last bracket is a closing one. So I can take this piece, just say, hey, I found ABBA. If there's something in the end, then I get 110. So, okay, let's have a look if this is right. Okay, that's the right answer. Let's do part 2 and then chat to the solution later. You would also like to know which IPs support SSL, super secret listening. An IP supports SSL if it has an area broadcast accessor or ABA anywhere in the supernet sequences outside any square bracket sections, and a corresponding byte allocation block BAB anywhere in the hypernet sequences. An ABA is any 3-character sequence which consists of the same character twice with a different character between them, such as XYX and ABA. Corresponding BAB is the same characters but in reverse positions. So for XYX it's YXY and for ABA it's BAB. For example, ABA, BAB, XYZ supports it. Okay, that's nice. Let's have a look at this then. XYX, XY, XY doesn't support because it doesn't have YXY. Makes sense. This one supports again. And this one supports ZBZ, BZB. Okay, how many IPs have this? Cool. So we'll just do something very similar, I guess. With different contains function. And this time they have to both contain. So found, let's just say ABA is false, and then let's just say outside. Then we have found BAB inside. We should find both things. And then we can do the same thing. We can reuse a string. ABA. Okay, we can't just check them independently, right? We have to say, we have to kind of store all the ones that we find and store all the other ones and then compare them. So we just say val ABA outside is a mutable of strings, and then BAB inside use a list of strings, and then I just have to find ABA and then I just add them to the list, and this is the outside list, and then I do the same with the inside list, and I can also find ABAs, and then the string thing is the same. Then I do outside once more. I can just paste it. And then for evaluation, I compare them, right? What's the definition? If it has a ABA outside of this square bracket and a corresponding one anywhere inside the brackets. Okay, so I just have to take these two lists for each ABA. BAB inside, BAB, just compare them. What's it called? Supports SSL. Let's just say false. And then if ABA 0 equals BAB 1 and 0 equals ABA 1, then this is true. If supports SSL, then we have R2. Bar R2 0, then we have to write this ABA function. Let's have a look. Or find ABAs or whatever. Returns list of string, so you have to like add all actually. What's BAB inside? Then we have to look at this. We want all the 3 length thingies, and if they have different and then the same, then then we add them to our result set. So we know that these are the same. We don't really need to store this last part, but we can just store it. These are different. Okay, let's have a go with these examples. Exception. Yes, this needs to be aligned. We want 3 length strings. And we want to print R2, and maybe we can not print here. Okay, AB has ABA. K has ABA, and ZBZ has ABA, and the other one doesn't. Nice, let's have a look with the real input. We have 242. And that's it for day 7. So let's chat to the solution. For part 1, we want how many IP support transport layer snooping, which means it has to have an ABA, and that's a 4-character sequence which consists of a pair of 2 different characters. So ABA, but not AAA. But AP is also invalid if it has an ABBA within the hypernet sequencing, which is the square brackets. So how can we do it, or how did we do it? The question is how many of these inputs are valid ABBA, so we just start counting. We go through each line. Line is just one line. And then I indicates each character index in the line. So we start by saying we have not found an ABBA, and we assume that the string is valid. So valid means there is no ABBA inside of a square brackets. Then we just have an empty string, which is a mutable list of characters, and we loop through our string per each character. So each character we go, hey, are you a open, closed, square bracket, or something else? If you're something else, we just add you character to my string. So the beginning goes like this. I add all these to my string, and then in each of those loops, increase I, so I get the next, and so on. Then I hit a open square bracket, at which point I want to evaluate my string that I have collected up until now by just make this list into an actual string. And then I call this extension function contains ABBA, and this returns true if I can find an ABBA in there, and false if not. So I assume there's no ABBA in at the beginning. Then I go through the string, and for each set of 3, so here I always get each set of 4 characters, I check it. So my string could be this, could be A, B, C, D, E, F, G, and then I want to split it in A, B, C, D, B, C, D, E, C, D, E, F, D, E, F, G. For each of those, I loop through, so that's why I do length minus 3 loops, because I need 4 to get through these separations of the string. And this is how I get it. I just do substring I to I plus 4, which is then the first iteration is this, and the second iteration is this, and so on. And then for one of those, I say, hey, is the first one not the same as the second one? Is the first one the same as the last one, and the second one same as the third one? If that's all the case, then we have an ABBA, and we say true. And then we just try all of them. If we didn't find anything, it's still false. If we find one, it's true, and we return the result, which is the Boolean of true or false. So then we evaluate this, and if it's true, we just set our variable to true. So then we can go through the rest of the string, and found ABBA will remain true because we have one. So at this point we can continue evaluating more things. So what we do is we reset the string, because we evaluated this part, and then we reset it, and we want to start collecting the next part between the brackets now. So that means we collected some more strings in our loop. We hit another bracket, but this time it's this bracket, so we are not interested in adjusting the found ABBA variable, because we're inside of the brackets, which means if there's an ABBA in here, our string is actually not valid because of this second condition. Must not have an ABBA within the hypernet sequences. So if we do the same thing, we evaluate a string if it contains an ABBA. If it has one, then our string is invalid, so we just set it to false. So at this point it can't be saved anymore. Even if found is true, we have false here, so it's invalid. Then we reset the string and go on, and then at the end, this one bug we had, we have to evaluate once more if we found an ABBA, because at the end we don't hit any bracket to start evaluating, we just stop. So we have to evaluate once more here. And then if we only if we found an ABBA and we're still valid, so we didn't invalidate it here to false. So if we have both to true, then we can count it, otherwise it's not. Either we didn't find an ABBA or it's not valid. And that's it for part 1. Then we just print the count of lines that go through this condition. And then part 2, it's very similar. We want to look at SSL, which is if there's an ABA in the string, and then we want a corresponding BAB in the string as well. And the BAB needs to be in the brackets and the ABA outside. So similarly, we can collect our string, and then what we want to check is the outside is a mutable list of strings. We just have to collect anything we find. So we go through here and say, is this an ABA? Is this an ABA? For each of our things. And if anytime we find one, where is one? Can't find one here. Here. Anytime we find one, we just add it to our list of API outsides. And the way we evaluate this is we start with an empty list, no AVAs. Then we do the same thing, we go through splitting our string, but this time into smaller parts. This time we want ABC, BCD, CDE, and so on. So we need one more, because we only split it into threes. And then we do a substring 0, 1, 2, 3. No, 0, 1, 2. So we have a length of 3. And for this string, if it's an ABA, that means it has different 0 and first characters and the same 0 and 2 characters. If that's the case, we can add it to our list. So if we didn't find any, this is an empty list, but if we found some, we return the result. Then the result gets added into this list that we just collect throughout the whole string. Similarly, we have another list for the ABAs inside the square brackets. We add them to this collection. And then also again at the end we have to add one more time all of the string from the end, check the ABAs we can find there and put them in the outside. And then we just say, hey, supports SSL is false, but if we find this combination, then we set it to true. And the combination is we go through each combination of outside and inside once, because we could have like ABA, XYZ, XYX here, and then we could have BCB and YXY here. So we need to find something that matches. So this doesn't match, this doesn't match, this doesn't match, and then okay, this matches. So we have one outside that XYX and one inside that's YXY. So we found one match, and that means it's true, and then we can count it. And yeah, that's basically it. Thanks everyone, and see you next time.